Good morning, good afternoon, good evening, ladies and gentlemen, and welcome to part 2 of using sinusoidal functions. So we're going to be taking a look at some word problems. So let's get started. So we read here, it says, a group of students tracking a friend, John, who is riding a Ferris wheel. They know that John reaches the maximum height of 11 meters and 10 seconds, at 10 seconds basically, and then reaches the minimum height of 1 meters at 55 seconds. Write an equation of the sinusoidal function that models John's height above the ground to determine his height at 78 seconds. So remember, in word problems, you always want to underline the important stuff. So he reaches a max height at 11 meters at 10 seconds. Reaches a minimum height 1 meters at 55 seconds. This is helping you to determine your period and, of course, your max and mins. All right, so let's take a look. So let's get started. Now, we know that he is going to be going in a Ferris wheel, and the Ferris wheel goes in a complete circle of 360 degrees. We're also given his max and min. We know when they occur. So let's do that. So we know that his max occurs, okay, at that time. So you have your minimum at 55 seconds. You have your maximum at 10 seconds. Which gives me 45 seconds. Now remember, when you're going from your max to your min, that's never your full rotation. That's always half of your rotation. If you remember from whenever we made our graphs from before. So 1/2 of a revolution. Now when we call going around a circle, we call that revolution. So 1/2 of a revolution is 45. Which means 1 revolution so going around the circle 1 time, we'll go over it in 90 seconds. Now, a revolution is another word for period. So because you're going around in a full circle, well, it took me 90 seconds, which means 90 seconds is my period. So let's use that. It means I'm going into my k value, because remember, you always want to find out your k. You're going to go 360 divided by 90. So we have 4 by k. All right. Okay, and now remember to get your amplitude. Let's do this. So if you want to find our amplitude, let's find our axis first. So we have our max, we have our min. Let's do that. So y is equal to max plus min. So my maximum height was 11. My min was 1. Divided by 2 gives me 6. Okay. So you know my axis is at 6. Okay, so how far away was my max from there? Well, let's do that. My amplitude, remember, is going to be max minus min. So my amplitude's 5. Okay? Which means my maximum should have been 5. But because my max is actually 11, so my max is 11, so this is how you find your C value. So my max is 11. This is usually made up of your amplitude plus whatever gave it there. So 11, I know my amplitude is 5. So C is going to be 6. Okay, so we found our amplitude, we found our C, we found our K. We can make our equation. So therefore, y is equal to, and this is always how your general equation should look, especially if you're going to use sine. It's going to be 5 sine 4 t minus d. I have no idea what d is. plus 6. All right. Now, let's continue on here. What if I wanted to try to find out what my d is? So let's try to use any of our times that we know of. So let's use the 10 seconds for time. Okay, because we know what those values are. All right. So at 10 seconds, I'm at 11 meters. So let's sub it in. So sub 10, 11. So you're going to get 11 is equal to 5 sine 4, 10 minus d, plus 6. Now you guys saw how we did this in the previous video, so it's the same kind of things. You want to isolate your 10 minus d here, so you want to move the 6 to the other side, so you're going to have 11 minus 6, which is going to give you 5. You want to divide both sides by 5, so it's going to give you 1. Okay. Then you want to take the sine minus 1. Alright, so you want to take the sine minus 1 of both sides. Which will give you 4 10 minus d. Let's continue this over here. Alright, so sine minus 1 of 1 should give you 90 degrees. Okay. So you should get 90 degrees there. For 10 minus d divided by 4, which should give you 22.5. And then you can move the d to the other side. You can do however you wish here, but I'm going to move the 10. This will give me 12.5. We're not done because you can't have negative d as your final answer, so d should be negative 12.5. Okay? So that means my equation, it would be y is equal to 5 sine 4 t minus minus, so plus 12.5 plus 6. Okay, so notice the steps that we had taken here, okay? So remember, the first step you always want to do is try to find out what your period is, and you do that by basically taking away your max from your min, or you always want to do the bigger values minus the smaller values here to find out what it is. But that's only ever going to give you 1/4 of your resolution, 1/2, sorry. And then the second step is you're going to find your k value, and of course find your amplitude and your c from there, and then find your equation, in which case you're going to find your d. Okay? Okay, so let's take a look at how another example would look. Alright, so let's look at this very, very, very big and wordy question. Sorry for the wordiness. So, the top of a flagpole sways back and forth in high winds, kind of like Fabio's hair. Yes, bad example. The top sways 10 centimeters to the right, plus 10 centimeters, and 10 centimeters to the left, minus 10 centimeters, of its resting position, and moves back and forth 240 times every minute. At t is equal to 0, the pole was momentarily at its resting position. That basically means it's at 0. Then it started moving to the right. Determine the equation of a sinusoidal function that describes the distance the top of the pole is from its resting position in terms of time, and then find its domain and range. Lastly, is the wind speed decreases slightly such that the sway of the top of the pole is reduced by 20%. What is the new equation of the sinusoidal function? Assume the period remains the same. Now, sorry, I do have some typos here. Sorry, so it's supposed to be if, not as. It's supposed to have an end of a bracket there, but let's get into this question. So, let's try to make it easier on ourselves first and foremost and turn the minute into seconds, because we know that 1 minute gives me 60 seconds. Okay? So let's go into here. So it says you have 240, it moves back and forth 240 times every minute. Okay, so if it goes forth 240 times every minute, or 60 seconds in this case, that would give me 4 cycles per second. Okay? So how much would 1 cycle be? Well, 1 cycle, if it's taking you 4 cycles per second, then just divide it by 4, so then therefore 1/4 of a second will give me 1 cycle, which is also my P. Okay, so my P would be 1/4. So let's find our K like we normally do. Use a different color here. So K is 360 divided by P. So 360 divided by 1/4, which is 1440. Okay. So once again, as normal, what would my amplitude be? Well, my amplitude, remember, you take your max, you take your min. What would we have here? Well, it's going 10 centimeters to the right, 10 centimeters to the left. So it's going by tens. So amplitude's 10. Okay. Now, do I have a C? I don't, because my max is 10 and I'm only at tens. So because I'm at the exact max that I should be at, then there is no C. So let's write our equation. So assume we're using sine. (1440 t). Now, why wouldn't I have a D here? Well, because it's not moving left or right. You are definitely into a sine function right here, because I know at t is equal to 0, that's why this line here is very important, the pole was at resting position. So basically at the beginning of my time, it was at resting position. If you guys remember, just to give you a visual representation, a sine function goes like this, up, down, up. So if it's already at resting position at t is equal to 0, then there is no shift left or right. It's definitely just in the general position. That's why this is a very important line there. Because it then starts saying, then it started moving to the right. Boom, boom, boom. So that's my equation. So domain and range, well, remember, domain, you're working with time here, so time such that, well, you can't have negative time, so it's always going to be greater than or equal to 0, as we explained before. Range, you want to go for your max to your mins. Okay, so my minimum is negative 10, as we say above, and my max is 10. And that's done. Let's look at the last part here. So the wind speed decreases slightly, such that the sway up the top of the pole is reduced by 20%. So if it's reduced by 20%, so you have 100%, it's reduced by 20%, which means you have 80% of it remaining. Okay? What is the new equation of the sinusoidal function? So assume that the period remains the same. So if it's reduced, you need to find what your new max and min would be. So what's 80% of 10 centimeters. Remember, you would take the 10, you'd multiply it by 0.8. That should give you 8 centimeters. So your new function would be 8 sine 1440t. And that's the end of this example. Let's look at our last example. Okay, this last example says the population of rabbits, R of t, and the population of foxes, F of t, in a given region are modeled by functions R of t is equal to 1,000 plus 5,000 cosine 15t, and F of t is equal to 1,000 plus 500 sine 15t, where t is the time in months, referring to each graph, basically meaning they want you to draw a graph. Explain how the number of rabbits and the number of foxes, not Megan Fox, are related. Okay, so let's take a look. So before we can make the graph, we just need to understand something. What do we need to understand? Well, for both functions, my k value is 15. Okay, and of course, and both of them, the time is in months. So what's my period? My period would be 360 divided by 15, which would be 24 months. So they both go along 24 months. So in this case, you're going to have to graph it. So let's do that. Let's take our graphs. Now, we know that we can put them into the same graph. Yeah, we can put them into the same graph. Let's do that. We'll use different colors, though, for their graphs. Okay. We have 5, 10. Let's go 5. Let's go 5s. So 5, 10, 15. They both have the same continuality, so let's have both of them split by 5s as well. So 5, 10, 15, 20, 25, 30, 35. Let's go up to 45. 40, 45. And we know this is t in months. Now remember, whenever you're making your graphs, you want to make sure you're fully labeling this stuff. This is going to be your y. Okay. All right. So let's go. Let's do this. Let's make the first graph. So let's go with our R of t first. So remember, your R of t, you're starting with cosine, and cosine always starts from the max, which is 15, then goes down. Okay, so let's see what this looks like. So we know that this usually is going to go up until this point. Oops. Let's do this better here. All right, so we know that this happens at 25. Okay, halfway between 10 and 15 should be one of the minimums. Okay, and we know that this would happen here, so the next maximum would be at 25. Okay, then the next minimum would be between 35 and 40. All right, so let's connect it. Okay, that's one graph. Let's draw the other one. Let's use blue for this one. So that one starts at the 0, which we know should start at 10. Okay, we know its max should happen at 5. We know that the minimum should be between 15 and 10. No, 15 and 20, sorry. The next max should be at 30. Okay. And then the next minimum should be between 40 and 50. 40 and 45, that is, sorry. So let's draw that. Okay, so let's take a look. So let's compare here. So in comparison, when I have my max, you're still kind of going downwards in both. So what am I noticing here? As the fox population, so actually let me just label these here. So this would be my f of t. And this is my r of t. So as my fox population begins to increase, the rabbit population begins to decrease. The rabbit population continues to decrease, and this has an impact on the fox population, since its food supply diminishes. So you can see that we start at max, but as the rabbit population goes downwards, you can see the fox population is going down as well. Okay? Because they don't have as much food. So the fox population peaks right about here. So once it peaks, where are we peaking? So we're peaking here for the fox population, and we're peaking here. What do we mean by peak? That means when they get to their max. So the second it gets to its max, it starts to decrease because they don't have enough food. Okay? Now the rabbit population gets to a minimum. So obviously it gets to a certain point where they've all been eaten and there's only a little bit of them left. And then they start to rise again, as there's now fewer foxes to eat them. So you can see there's fewer foxes to eat them. Okay? As the rabbit population increases, what do we then notice? The food becomes plentiful. As the food becomes plentiful, the rabbit population is now going to, the fox population is now going to increase because they're going to be eating. And of course the whole cycle takes place over over 45 months, so about 2 years. And that's what we're noticing here. And that's how you can use a graph to explain a scenario or a certain situation. You can tell a story out of a graph. Graphs do tell stories. Okay, I hope you've understood all these examples and have yourself a great day.